Now let's carry on with our discussion of inferential statistics. And um, now we're going to learn to do inferences for two groups, and we're going to start with proportions again. So what we're asking here is the proportion of something in one group the same as it is in another group? And these are two independent groups. And the confidence interval for these is a little bit more complicated because we have to deal with a standard error that is pooled from two samples. So notice instead of just p times 1 minus p over n, we have the square root of p times 1 minus p over n for group 1 plus p times 1 minus p over n for group 2. And when we put that into the confidence interval formula, that's the whole standard error. Here's our z, our usually 1.96. And what we have for a point estimate is the difference between the two groups. Okay, so the difference in their proportions. So here's an example. Who has worse knees? American football players or European football, aka soccer players? Okay. And it turns out that it depends on what you mean by bad knees. So suppose researchers studied 220 football players and 180 soccer players, and they were studying male professional players. And the proportion who had knee problems was as follows. For CL problems, the soccer players had a higher incidence. So they had 51%, whereas the football players had 40%. But for ACLs, the football players had the higher incidence at 36% versus only 13% for soccer. So we're going to focus on the CL for right now, but you can certainly go back and try this with the ACL too. Also, by the way, there is a study that offered comparative data on injuries in football and soccer for men and women. And in general, the ones who have the worst knees are women in soccer. So that's an interesting finding. Okay, so let's do the confidence interval for the difference in CL injuries for these two sports. And so we're only looking at collateral ligament for soccer 51%, for football 40%. And then we've got this is our formula for the confidence interval. Okay, so we're going to work this out on the next slide, but just for now, that gives us 0.51 minus 0.40 plus or minus, oops, there we go, plus or minus 1.96 times big square root, 0.51 times 1 minus 0.51 over, what was that in? 180 soccer players, 180 plus 0.40 times 1 minus 0.40 over 220 football players. Okay, that's how you set up that whole equation. Doing this on a calculator or in R or anywhere else, use a lot of parentheses to keep this straight because you can get into a lot of trouble with all of this stuff under the radical and everything if you're not careful. Okay, so this is what this looks like. We just wrote that out. The difference, the point estimate of the difference is 0.11 right here. Okay, that is the point estimate. So, and then we have the 1.96. All that mess under the square root comes down to 0.05. So you have 0.11 plus or minus 0.096. And so the confidence interval is from 0.014 to 0.206. Now, notice here, the thing to note, because this is about difference. So note 0 is not in there. Okay, so what this is saying is that you have 95% confidence that the difference is not 0. Okay, meaning there is actually a difference. So the question is always, could this difference be due to chance? Okay. And remember, if the confidence level is 95%, then the alpha rate is 5%. So there is a chance that it's due to chance. So we can think about this a couple of other ways. One is with a randomization approach, and one is with a hypothesis test, right? So think about collectively, if we add up all of the injuries and all of the people, we have 180 injuries out of 400 players, which means the overall proportion of injuries is 45%. Okay. So if that was true, does the fact that we end up with slightly more than that in soccer and slightly less than that in football mean that there's a real difference, or could it be due to chance? So that's what we're going to do in the next two sections. Is we're going to do it as a hypothesis test, and we're going to do it with a randomization approach. Like bootstrapping, randomization uses a simulated approach. So we're definitely going to have our code to look at that. That's it.